Bam! Mr. Tarrou, in this algebra lesson, we are going to be going through 4 examples. Actually, one of those examples we're going to do twice that involves fractions, so you can get a different look on how to do that problem. So maybe 5 examples on how to solve multiple step equations. Now we just moved from 1-step equations to 2-step equations. I'll put links to those lessons down in the description. And there's also going to be timestamps to skip ahead to each of our 4 examples as well if I do one you think is too easy and you want to see a different example. And they will go from easy to hard. And in this video, all 4 examples we're going to deal with are going to have the variables on one side of the equation sign. And the next lesson that we have is going to have equations on both sides. Just every lesson in this algebra series, these equations are going to become a little bit more difficult. So we're going to distribute, if there is any, to remove any parentheses. We're going to combine like terms. Those are going to be terms that are on the same side of the equation, whether they're both on the left or both on the right, that we can add. Maybe they're both constants. Maybe they're 2 terms that have the same variable. We're going to add or subtract away from the variable, because hopefully with the types of problems we're dealing with in this lesson, after we get finished with step 1 and step 2, we're going to be ready to start moving terms or factors away from the variable. Whether that, if that variable's on the left side, we're going to move everything to the right. If that variable's on the right-hand side, we're going to move everything away from it and move it to the left. And then our last step is going to be to multiply or divide away from that variable. Once we have finished isolating that variable, solving for it, so that it is just like x is equal to some kind of number, we're going to make sure that that is actually a correct answer. If, or does the number that we found at the end of our problem, when plugged back into the original problem, does it make the 2 sides of the equation equal? Because that's what a solution is. Something, a value that you can plug into an open sentence and have, the left side be the same value as the right. Okay, now, these 4 examples also are going to be just purely algebraic. I'll have at least a couple of links in the description of this lesson if you have trouble setting up word problems, where you can go to find other lessons where I've discussed how to do that. Or at least, well, they're all different, right? They can be kind of complicated, but some suggestions for some examples. So we have 10 minus y again is equal to 34. What is the value of y that is going to make the 2 sides of this equation equal or equivalent? Well, our equal sign is right here, separating the left and right-hand side of the equation, and all the action is on the left-hand side. Well, we don't have any parentheses to worry about distributing, some kind of value through those parentheses, and the parentheses are just a grouping symbol. Eventually, as you move up through your mathematics classes, you'll have parentheses with exponents and maybe some division. With our examples at this point of our algebra studies, we're just going to have a number in front of those parentheses that we have to distribute or multiply through. I'm getting ahead of myself, though, because that's going to come up in our examples. So then we're going to combine like terms. What are your terms? And by the way, terms are separated by addition and subtraction again. So we have 2 minus signs giving us 1, 2, 3 terms. A term can be just simply a variable. It can be just a constant. It can be a combination of variables and constants that are multiplied and or divided together. And we have some like terms here of y. Okay, we have 2 terms. They both have a coefficient of 1. And they're like terms not only because those 2 terms have the same variable, but it's the same number of variables. We have a y to the first and y to the first. If this had a y to the second, so this term only had 1 y and this term had 2, those would not be like terms. But we do have 2 like terms on the left side. We are going to be combining those 2 like terms by whatever math operation that we see in the problem. And we have a -1 minus 1. Well, starting from 0, -1 is a movement to the left 1. Maybe that would be by this coefficient. And then move to the left once again. And that's going to land us at -2. When you're combining numbers with the same sign, this is for addition or subtraction, you want to add those numbers and keep the sign that you have. So we have 10 minus 2y is equal to 34. Now we only have one variable in our problem. It's on the left-hand side of the equation, so that we're going to identify what else on the left-hand side with it and move it over to the right. These are suggested steps, by the way. You don't have to go through these 4 steps exactly in this order, but that's my suggestion. I believe is going to help make these answers, these problems work out as easily as possible. So on the left-hand side, we have a positive 10 and we have a -2. Well, the -2 is touching the y. That indicates multiplication. And we're ultimately going to, at some point, have to undo that multiplication with division. But if I divide by 2 now, these are all even numbers, so I'm not going to create any decimals or fractions, but sometimes that'll happen when you divide. And I don't want to carry those decimals or those fractions through the rest of my problem, and that's why I'm suggesting add or subtract away from the variable as my third step, and avoid creating any necessary complication in the problem, unnecessary complication. So we're going to subtract both sides by 10. I see a negative there, but that's for the 2. This is a positive 10. There's nothing out front. And we're going to, well, 10 minus 10 is 0. So that's going to leave us with negative 2y is equal to 34 minus 10 is going to be 24. And now we need to divide by that negative 2. Why are we dividing? Well, why did I subtract? Because that was the opposite of an addition of 10. Well, what's the opposite of multiplying by 2? We want to undo that multiplication with division. And so now we get y is equal to negative 12, and we need to check that answer. We need to be able to plug this negative 2 back into the original problem and see if it makes the two sides match. So let's see that check right now. So as you can see, we've taken our value of negative 12, plugged it in with parentheses. Every time you do substitution, you should get in the habit of taking out that variable and in its place putting in a set of open parentheses, and in that place of y we've plugged in negative 12. Now in this particular problem, the reason why it's really important for you to use parentheses before you do substitution is because I don't want you to think of that negative that's in the equation and sort of think that it somehow is already accounted for with this negative in the 12. Or basically it's really easy for students to forget that they need to write both of those negatives. So we have 10 minus y is equal to 34. And then hopefully what you can see here is, if I pick a different colored chalk, is these two negatives are canceling out. Well, the reason why they're doing that is because in between that negative sign and the open parentheses, really you can think of as a negative 1 there, and a negative times negative, or negative 1 times negative 12 is positive 12, and we have the two sides matching, which they're both equal to 34, so we're validating our answer. Okay, so for our next example, we are going to have, let's see here, we're going to have the example number 2. We're going to solve 5 is equal to 4 minus, parentheses, 3 minus 2x, close parentheses up, plus x. And we have to find some room to do a check for this one. Okay, so what we've got going on here, the reason why I'm giving you this as an example is, one, the variable is on the right-hand side of the equation. We can take care of that two ways. One, we can just say, okay, well, the variable's on the right, so we're going to move everything away from it and move it towards the left. We can also take the two sides of this equation and just sort of basically move the stamps around and write it like this, even though I'm not going to, I do want to show the work with the variable on the right just to get you more comfortable seeing that. But you could, if you wanted to, write 4 minus parentheses 3 minus 2x plus x is equal to 5, and then, finish the problem off. If you're going to get in the habit of switching the two sides of the equation to keep the variables on the left, you will have to be a little bit careful when you start solving inequalities, because you'll have to remember to change the direction of that inequality when you set that up. Okay, and another thing is, actually I'm pausing and I just heard a little bit of static in the microphone, so let me change the batteries and make sure we don't get any more of that, or try to make sure we don't get any. Okay, let's see if that helps. Now, besides just wanting to have you get more comfortable with the variables being on the right-hand side, not just always being on the left, is I also picked this problem as an example, or came up with it as an example, because of this mistake that I see students do all the time. Here we do have parentheses, okay? So we're going to need to distribute to remove the parentheses. And instead of just doing a problem that has a number in front of the parentheses, the vast majority of my time my students get those correct after they do a couple of examples, but they will still miss problems like this. Because what they'll want to do, and I'm going to, please don't remember this because I'm trying to show you the wrong way, is they want to take the 4 and they want to multiply it through the parentheses, and that just isn't right because it's 4 minus the quantity that we have inside this parentheses. If we want to distribute, what we need to remember is, again, like I showed you in the last example, that between the negative sign and the parentheses, you need to account for or think of or just come in here with your pencil and put a 1 between the negative sign or the minus sign and the open parentheses. And that is hopefully going to remind you that when you do the distributive property, because, well, again, the distributive property is multiplying a factor through the parentheses or through a set of parentheses, we're going to be multiplying the negative 1 through the parentheses, okay? And that's what we're going to distribute, not the 4. It's 4 minus all of this, not 4 times. Like if there was nothing there and it was 4 parentheses, that's when you would want to multiply the 4 through the parentheses. So we have 5 is equal to bring it, do one step a line, bring everything straight down. We have 4, negative 1 times 3 is negative 3. And we have negative 1 times negative 2, which is positive 2x plus x. And so now we have distributed the negative 1 through the parentheses. We don't need it anymore. And here is our new equation. Now, we want to combine like terms if there are any on the same side of the equation. I mean, the 4 is a constant and the 5 is a constant, so they're like terms as well, but they're on different sides of the equal sign. So just looking at this expression, 4 minus 3 plus 2x plus x, let's combine all the like terms, and if you like, again, give yourself a reminder, jot down that x has a coefficient of 1. So our like terms that we're going to combine, let's use some different colors. We have a positive 4 and a negative 3. Those like terms are going to come together through, addition slash subtraction. 4 minus 3 is going to be equal to 1. And then we have another set of like terms. We have positive 2x and positive 1x. And so bringing those together, we have 5 is equal to 1. Positive 2 plus 1 is going to be equal to 3x. Now, these are not like terms. This is just a constant, and this term has a factor of x, so these can't go together. We're going to add or subtract away from the variable, and our last step is to multiply or divide away from the variable. Well, with my variable, I have a coefficient, a multiplication of 3. I could undo that multiplication of 3 right now by dividing everything by 3. But now I'm going to have fractions in the form of 5 over 3 and 1 over 3 that I'm going to have to deal with through the rest of the problem. And I don't avoid fractions. I don't immediately always get rid of them in my problems for you guys because we need to get comfortable with them. Fractions and rulers, they're on measuring cups, there are all kinds of places that we deal with fractions. And, don't just grab the calculator and turn that into a decimal. But, if you don't have to create fractions, why would you want to? So on the right-hand side with the x, we have an addition of 1. We have a multiplication of 3. We would like to solve this as simply as possible. So we're going to undo that addition of 1 that's on the right by subtracting both sides by 1. Once on the left side of the equal sign and once on the right. That gives us 4 is equal to 3x. And then finally, we're going to divide both sides of the equation by 3 because I want to undo that division, that multiplication of 3 that's with the x, and we have 4/3 is equal to x. Now, is that the correct answer? Make sure that you check your work. And by doing so, what we're going to do, or how we're going to do so, our check is going to be 5. Is that equal to 4 minus, parentheses, 3 minus 2 times 4 over 3. I'm running out of room here. Whoops. Plus 4 over 3 again for that other x. But I'm getting a little bit sloppy, and I don't want you to... I spent a lot of time working very slowly with fractions in my previous lesson. I want to make sure I keep this, this particular lesson as short as possible, but while being thorough. So let me step off and show you all the steps for solving or checking the solution. So I've taken my 4/3, I plugged it in for x, like you saw me right before I started showing all the steps. I wrote my 2 over 1. Once you start dealing with fractions, let everything look like fractions so you can see the numerators and denominators line up. So I wrote 2 as 2 over 1, and 2 times 4, 2 times 4 is 8, and 1 times 3 is 3. I'm going to now write that 3 as 3 over 1. So again, getting those numerators and denominators to line up. Well, when you multiply fractions, just multiply across the top and the bottom. But when you're adding or subtracting fractions, you need common denominators. So I'm taking that 3 over 1 and I'm multiplying it by 3 over 3 because I want to get the 1 to be a common denominator with my other fraction, which is 3, my lowest common multiple. And I'm multiplying by 3 on the top and the bottom because 3 over 3 divides out to be 1. So I'm just multiplying 3 by 1, except when it's written as 3 over 3, it's going to change its look without changing its value. So 3 times 3 is 9, and 9 over 3 minus 8 over 3, well, now that we have common denominators, we just add or subtract those numerators, and 9 minus 8 is equal to 1. So now I've got my 4 written as 4 over 1, so I can match up with the numerator and denominator of 1 over 3 and 4 over 3. Well, with denominators of 1, 3, and 3, again, that common denominator, the lowest common multiple is going to be 3. So again, with a multiplication of 3 in the numerator and denominator, we get 4 times 3 is 12 over 3, and 12 minus 1 is 11. 11 plus 4 is equal to 15. Excuse me, and then 15 over 3, well, that comes out to be 5, which is the value of the left-hand side of the equation. Thus, when we plug 4 over thirds back into our original equation, the left side and the right side are both equal to 5, so we are done with this problem. Next example. Example 3. We've got 2/3 n plus 1/2 times n plus 8 is equal to 5 over 6. Of course, I'm going to do all the problems with fractions because that's probably what you're going to have questions about. Why do the easier ones? Let your textbook examples deal with those, or your teacher in your live class. We're going to take this 1/2, we're going to multiply it through the parentheses because we have 2/3 n plus 1/2 times. Whenever a number is touching a parentheses, whenever a number is touching parentheses, or a number constant and a variable are touching, of course, that means multiplication. So we're going to distribute the 1/2 through the parentheses. So we're going to have 2/3 n plus 1/2 n, and then I could, maybe just for practice or for good teaching, I should go ahead and put that 8 over 1 so you can see the numerators and denominators line up. But I hope a lot of us can just say, well, that's a half, and half of 8 is equal to 4. And then we're equal to 5 over 6. So just leaving the fractions in the problem and dealing with it, I'll show you how to get rid of those in the second form of this example. I'm not going to check my solution for this one. We're just going to work it out 2 different ways, and you can pick which process you prefer better, or do whatever your teacher requires. So we're going to subtract both sides by 4. Well, if I'm going to do 5 over 6 minus 4, then I need, if I have one fraction, I need everything else to look like fractions, and that means we're subtracting by 4 over 1. And we have numerators of 5 and 4 and denominators of 1 and 6. Well, if I need to take this 1 and multiply it by 6 to get the lowest common multiple between 1 and 6. So we're going to multiply the numerator and denominator by 6. Again, 6 over 6 is equal to 1. I'm not changing the fraction's value, just the way it looks. And we have 2/3 n plus 1/2 n is equal to, I probably should have finished my work here. We have 5 over 6 plus negative 4 times 6 is negative 24 over 6. And now, we have a plus negative. Well, that's the same as subtraction. So basically 5 minus 24 is going to be negative 19 over 6. Okay, so now on the left-hand side, we are going to, I just went out of order of my suggested order that I gave you to do these problems, and that's okay. That hasn't led to any additional difficulty. The first thing I did was multiply, get rid of parentheses, but then I started to move away from the variable, which now I'm realizing I didn't do that either. Well, there is the equal sign separating the left and right-hand side of the equation. our variables are on the left, so we're going to need to move all the constants and factors and terms away from the variable that we're trying to solve for, which is n, on the left-hand side. And so that's why I subtracted both sides by 4 to move it away from the value or the variable of n. Well, now I have 2/3 n plus 1 over 2. The lowest common multiple between 3 and 2, this isn't, well, these are prime numbers, so it's going to look like I'm just flip-flopping these around, but the multiples of 3 are 3, 6, 9, 12, and so on. The multiples of 2 are 2, 4, 6, 8. Oh, okay, there we go. Our lowest common multiple is 6. So the 3 needs to get multiplied by 2, because that's the second number in the list. So we're going to, and 3 times 2 is 6. So we're going to multiply by 2 in the numerator and denominator of our first fraction. And to get to the lowest common multiple of 6, we need to multiply 2 by 3. So we're going to multiply this 1/2's numerator by 3 and denominator by 3. And now we've got 4 over 6 n plus 3 over 6n is equal to negative 19 over 6. And, well, on the left-hand side are like terms, those terms separated by addition and subtraction that have the same variables and the same number of those variables in the form of equal exponents. We're going to add these fractions, but they already have common denominators. So we're just going to do 4 plus 3 is equal to 7 over 6n is equal to negative 19 over 6. And when you have a coefficient in front of a variable that you're trying to solve for, and we're at the very last step, we're almost done, that coefficient is a fraction. Well, I need that coefficient to be 1. And I don't know why I'm holding up 2 fingers. And if you want to multiply a fraction by some value that is going to create a coefficient of 1, you want to multiply both sides by the reciprocal. I want to take the 7 over 6 and I want to flip it and write 6 over 7 and multiply that 6 over 7 to both sides of this equation. And going across this multiplication symbol, it wouldn't work for addition or subtraction, 7 divided by 7 is equal to 1, and 6 divided by 6 is equal to 1. So we just have n is equal to, well, over here, again, across this multiplication sign, don't do this kind of canceling across an addition or subtraction, 6 divided by 6 is going to be 1. So kind of basically just doing a reduction before I multiply. Negative 19 times 1 is negative 19 over 1 times 7, which is 7. And this is the answer to our problem. And let's see. Yep, it's exactly what I got before. Awesome. Well, that's example number 3. Except, you know, what if you... Man, I struggle. I really don't want to say this, but... You know, what if you want to get rid of, you don't want to do all this fraction work through the middle of your problem. Maybe just save that for the end when you go to plug this back into the original problem and check your answer. How can we take 2/3 n plus 1/2 n plus 8, right? Yeah, is equal to 5 over 6. What can I do to that equation to eliminate all of the fractions before I even start the problem? Well, again, going back to that lowest common multiple. When you look at 3, the lowest common multiples are 3, 6, 9, 12, 15, and so on. The multiples of 2 are 2, 4, 6, 8, 10, and so on. The multiples of 6 are 6, 12, 18, and look, our lowest common multiple is equal to 6. So if I multiply the entire equation by 6, I can get rid of all those fractions. Well, why is multiplying by 6 going to get rid of the fractions? Well, what math operation does a fraction represent? A fraction represents division. What's the inverse math operation of division? Though I have a bad habit of calling it opposite math operation, but what's the inverse math operation to division? Multiply. So if you have division that you don't feel comfortable with or you don't want, undo that division by multiplying. And we're going to multiply both sides of the equation by 6. Now the question is, how many times am I going to multiply? How many terms, every single term in that equation needs to get multiplied by 6? Well, how many terms are there? Because I see some stuff here. I see like n plus 8. That looks like two separate terms here. We have a 5 over 6. But the n plus 8 is wrapped in parentheses. That parentheses is holding all of this together to be one term. So this problem has 1. There's a plus or minus that separates terms. 2. I see a plus there, but it's in the parentheses, so that's the second term. And now on the right, we have one term on the right, giving us a total of 3. So we need to multiply by 6 3 different times. And I'm going to get, write that over 1 to make sure all the numerators and denominators line up. 6 times 2 is 12 over 3n plus 6 times 1 is 6. 1 times 2 is 2. n plus 8 is equal to 6 times 5 is 30. 6 times 1 is 6. Now, see, this time I'm not reducing the multiplication before I actually do the multiplication. I'm actually still writing fractions. Well, hello, I thought the whole point of this was to not have any fractions and maybe simplify the process of solving this equation. Well, what's 12 over 3? What's 12 divided by 3? That's equal to 4n. What's 6 divided by 2? That is equal to, what am I writing a plus sign for? That is equal to 3. n plus 8, and 30 divided by 6 is equal to 5. And you'll see some numbers that were probably, actually there in the first place, like my 5. Well, yeah, 6 divided by 6 is 1, and so that completely canceled out. But 6 divided by 3 is equal to 2, and then 2 times 2 is 4, just in case you want to do this a little differently. 6 divided by 2 is equal to 3, and then that 3 times 1 is equal to 3. Now, we kind of sort of have a fourth example, if you will, even though I said there was only 4 to begin with. Now we're going to take this coefficient that's in front of the parentheses. We have a multiplication of 3. This is the kind of distributive property that my students get right a lot of times, and they just mess up when there's a minus, like I showed you earlier in our lesson. So we have 4n. 3 times 1n is equal to 3n, positive 3n. Positive 3 times positive 8 is positive 24 is equal to 5. And by the way, did you notice that I did not write the plus or minus? I didn't write like a sign in addition or subtraction until I actually did the multiplication. I didn't see a plus there and go, oh, plus. I didn't see a plus there and go, plus. I said, no, positive 3 times positive 8 is positive 24, and that's when I decided to write the addition sign. If this was like, say, negative 3 times positive 8, and I said negative 24, I would have wrote minus 24. Okay, now, again, I need to get in that habit of make sure I isolate for you guys where the equal sign is. My variable's on the left-hand side, right? So I'm distributing to get rid of parentheses. Actually, first thing I did was get rid of fractions. And then I distributed to get rid of parentheses, and now we're going to combine like terms. Well, on the left-hand side, my like terms, I have a 4n, a positive 4n, and a positive 3n. Well, putting those like terms together, positive 4 plus 3 is 7. n plus 24 is equal to 5. With the variable on the left-hand side, we have a multiplication of 7. I can undo that now if I want to, but if I save it for last, I'll simplify my process. We're going to undo that addition of 24 that's on the left with the variable by doing the inverse math operation of subtraction. Anytime you want to get a number over the equal sign, over that line from one side to the other, whether that's left to right or right to left, you want to do that inverse. Okay, so now we have 7n is equal to negative 19. And to undo that multiplication of 7, we're going to divide. And lo and behold, we get the exact same answer as we did before. Ooh, well, no, we didn't make any mistakes. Hello. There's not just one way to solve these problems. Here, we dealt with all the fractions all the way down, and here, I showed you how to get rid of them. One last example coming right up. 2/3 times x minus 21 is equal to 10. Now I have two choices here. we can take this fraction and multiply it, distribute it through the parentheses. Let's not forget that we have a coefficient of 1 in front of the x. And we're going to, for the 21, go ahead and place a denominator under that 21. So again, those numerators and denominators line up. We have 2/3 times 1 is 2/3 x. And 2 times negative 21, again, look, see, not writing an automatic plus or minus. 2 times negative 21 is negative 42 over 3 times 1, which is equal to 3, which then is equal to 10. Well, there is 1, 3, and 4. That would leave you with 12, which means that we would 3 can also go into 12, which is going to be 4 times. So we have 2/3 x minus 14 is equal to 10. And I could have also done here, never mind, I think that's probably the best way. We can maybe do some kind of cancellation with the 21 and the 3, but going across a plus or minus and doing that kind of cancellation, though we are doing multiplication, I don't want you to see that and maybe possibly do some cancellation when it's not appropriate. So, and then we can finish this problem. But now, at some point, we're going to have to deal with this coefficient of 2/3 by multiplying both sides of the, actually, let's just do that now. Let's add the 14 to both sides. And we're going to get 2/3 x is equal to 24. We're going to say, hey, we have 2/3 times one item is equal to 24. Well, if I want to undo that coefficient of 2/3, we're going to multiply both sides of the equation by the reciprocal, which is 3 over 2. And that's going to be 6 over 6. Well, 6 divided by 6 is equal to 1. That when you multiply reciprocals, your answer is always equal to 1. That's how you kind of check to make sure you have reciprocals. And over here, let's put that 24 over 1. We are multiplying, and 24 divided by 2, doing a little cancellation there across the multiplication sign only. I can only do this kind of cancellation across a multiplication sign. 24 divided by 2 is 12, and then 12 times 3 is going to be equal to 36. I'm just checking my work. Yes, that is the right answer, and we can also check it by plugging it back into the original problem and making sure that indeed the two sides are equal. I can also look at this problem another way, going back to this idea of 2 over 3 times one item is equal to something. And we just multiplied both sides by the reciprocal. That's how you can get rid of the fraction right from the very start. We have 2/3 times a set of parentheses, which is holding whatever is inside of it together as one, well, thing. This is all being one term here. We have x minus 21 is equal to 10. Well, I could go, hey, I don't want to distribute that 2/3 through the parentheses. I want to get rid of the 2/3 right off the bat. And there's actually, now that I'm doing this, there's other ways you can work out this problem as well. But I just wanted to show you that you could multiply both sides of the equation by the reciprocal right off the bat, because those parentheses are holding all that together as just one term, just like we have here. And so 3 times 2 is 6. 2 times 3 is 6 again. 6 divided by 6 is equal to 1. So we have 1 x minus 21. That 1 multiplying by 1 doesn't really do anything, so I'm just writing that as an academic exercise. Over here, let's put that 10 over 1 so we see the numerators and denominators line up. You can, again, across a multiplication sign, 10 divided by 2 is equal to 5, and then multiply by 3, or if you want to, 10 times 3 is 30 over 2, but at some point you're going to write x minus 21 is equal to 15. And now, on the left-hand side of your equation with the x, you have a subtraction of 21. You want to undo that with the inverse math operation, which is instead of subtracting 21, add 21, and we get x is equal to 36, the same answer that we had before. I don't really want you to check your answers by doing the same problem twice. If you want to check this answer, make sure you can plug 36 back into the original problem, and in this case, get the two sides to both equal 10. Our next lesson is going to be dealing with solving linear equations where the variable is on both sides. I'm Mr. True. Go do your homework.